Extraction of casein from milk. Casein is a vital storage protein found in milk. Existing as globules within the milk, casein precipitates out of the solution when heated and exposed to acid. Here are the materials needed for the experiment: a filter cloth, rubber band, distilled water heated at 40 degrees Celsius, vinegar, ethanol, and whole milk powder. To start, heat water at 40 degrees Celsius. Measure whole milk for about 2 spoonfuls or 5 grams and put it in the container. Pour 30 milliliters of the water into the milk and mix. Add, drop by drop, acetic acid or the vinegar while stirring the milk suspension. Observe the precipitate formation. Filter the mixture using the filter cloth fastened by the rubber band into the glass mouth. Gently squeeze the mixture to remove water off the precipitate. Scrape the precipitate and put it into a clean container. Add 10 milliliters of ethanol to the container. Mix the sample for 5 minutes. Then, repeat the filtration by gently squeezing excess ethanol. Discard the liquid filtrate since it contains fats. Spread the casein on paper and dry. The isolate appears as an amorphous white solid and they look like sand aggregates. When you try to touch and feel, the consistency is grain-like. Casein-like proteins are made of amino acids that may have positive or negative charge, depending on milk's pH. At some pH, these charges will be in balance, giving the net charge to 0. This pH value is known as the isoelectric point or IEP and is generally the pH at which the protein is least soluble. Casein has an IEP of 4.6. This is where both molecules attract with each other tightly and the aggregates precipitate out of solution. However, milk has a pH of 6.6, making it soluble to water. The purpose of adding vinegar, an acid, is to lower the pH to 4.6 to help casein be insoluble to water, making them aggregate with each other, thus forming the precipitate. Casein precipitate contains fats, translating a micelle since we use whole milk that contains 3.5% fat. Adding ethanol separates the fat from casein. Fats are nonpolar. Ethanol compared to water is more nonpolar. Simply in chemistry, like dissolves like. So ethanol will dissolve fat. Casein will not dissolve in ethanol since binding is only from the ethanol methyl groups with the hydrophobic pockets in casein that of fats, since they are globules as we say. Although the mechanism is still unclear, it is hypothesized that the presence of a nonpolar solvent, such as ethanol, promotes dissociation of casein from the hydrophobic fats.